Hello. So today I have a puzzle by Lisztes, and it's going to be a showcase, and I'll explain why. So yesterday I saw this in the Discord, and I immediately wanted to solve it because, as you can see, it's called Fight Club for a very good reason. We have right in the center here, made out of palindromes, actually, is the Fight Club soap. And I do really like the movie Fight Club. So as soon as I saw that and seeing that it was Lisztes, I was like, okay, I want to solve this. But I looked at the reactions on Discord, which, if you don't know, those are how people rate the puzzle, and no one had solved it yet. So it was pretty new. So I said, well, maybe I'll be able to solve it live. And maybe it's not that hard. Some of his puzzles are harder than others. And just by looking at it, I couldn't tell immediately that it would be super hard. But anyway, I then proceeded to record a 3-hour-long live solve where I broke the puzzle 3 times and then realized I had to start over from the beginning after 3 hours and that it was a failed live solve. So that video is not seeing the light of day. I ended up failing it so many times because I made a mistake super early on and I never undid all the way back there. So like within the first 10 minutes of the video, I'd already made the mistake and it took me 3 hours to find that. So hopefully you don't have the same experience as me. The mistake was dumb. It's not something that you would naturally do. It was just really dumb on my part. So don't get discouraged there that it took me 3 hours, because I think probably I could have solved it in less time had I not accidentally made that mistake. Well, you know, there's no way we'll ever know. But I messaged Lisztes about that, and he's like, well, if you want to do a showcase, I can give you the best path, the intended path. And I decided that I would take him up on that offer because I did want to feature the puzzle, and I'd already fiddled with it for 3 hours, so I pretty much knew how it worked, I thought. But then he gave me this path, and I was like, oh, I didn't know how this worked at all. So anyway, I'm gonna showcase this puzzle with the intended path. In case you get stuck, you will know what to do next, unlike myself. But please do give it a try first. I'm going to go over the rules. So the first rule is you don't talk about Fight Club. The second rule is you don't talk about Fight Club. And then we have normal Sudoku rules and Antiknight. So I haven't really featured Antiknight too many times on this channel, if at all. I guess the Miracle video did have Antiknight. So I did go over some strategies there, but just in case you didn't see that video, the Antiknight rule means if you pick any cell, let's say this cell here, and you think about the Sudoku grid as a chessboard, then where could a knight go from this cell if you play chess? Well, you go 2 in one direction and 1 in another direction. So you go here, here, any of these cells that I've highlighted are a knight's move away from this cell. And whatever digit we put in this cell cannot appear a knight's move away from it. So whatever digit we put in this center cell cannot be in any of the cells that I've highlighted. And that's true of every cell in the Sudoku grid. So this one, these two can't be the same, as well as these are in the same box anyway, but even if they weren't, they couldn't be the same, and etc. So you just end up drawing this interesting sort of circular pattern around the cell, and none of them can be the same digit. And additionally, we have gray squares and gray circles. So the gray squares are even and the gray circles are odd. That's pretty standard for how that gets represented. These pink lines, I think I mentioned, are palindromes. So what that means is, starting from one end, if you look at the very other end of the palindrome, it's the same. So if this were a 2, this would be a 2, for example. And then the way the palindrome works on the C is it comes all the way around. So these two are the same and these two are the same. And then this is the center of the palindrome. So it's not the same as any other cell. Well, I mean, palindromes, you can repeat digits. There's no specific restriction there. But what I mean is there's no palindromic equivalent to the center of a palindrome. And then for the F, we actually have 3 palindromes that happen to connect. So we have this palindrome here, which basically just means these 2 cells are the same. We have this palindrome here where these 2 cells are the same. And then we have this 3 long palindrome here. So don't assume that there's like a palindrome that's 4 long like that. That's not how this works. So we have this palindrome, this palindrome, this palindrome. There's 3 different palindromes there. Okay. The next rule is we have these inequality signs, and they mean pretty much what you'd expect. They're kind of like a two-cell thermo. So this cell here is smaller than this cell, and this cell here is bigger than this cell. This cell here is bigger than that cell. So it's just the direction of the inequality, and just a normal greater than or less than sign, however you want to view that. And finally, we have two sums. So the sum of all the cells that make up this F, so these 5 cells, they sum to 28. And the sum of these 5 cells that make up the C sum to 23. And of course, all the rules will be in the description below and are in the link as you solve. The rules are on the left, so you can reference them. Obviously, the first 2 rules are the most important, so I don't want to see anything about that in the comments. And otherwise, do try the link below, see how far you get. You can always reference this video if you get stuck, try to get unstuck, and then continue. If you do manage to solve it, I'd love to hear it and how long it took you. As you know, it took me 3 hours to fail it. So maybe you'll do better than me. Hopefully you will. So go ahead and give it a try. And I'm going to get started on the walkthrough of how to solve this. So I think everyone should be able to see that, yes, we have 4 givens, but really we have 8 givens because the givens are on the palindrome. So if you look at where the equivalents are of these cells, this is 1999 because these 2 cells are the same, these 2 cells are the same, and we just walk our way down, and that gives us 1999. And so we can see that 9's in one of these 2 cells, and circle is odd, so it can go there. We have a 9 up in one of these 2 cells, and I believe that is the useful marks for 9's. We can also mark some 1's in the grid. So these 2 can't be 1 because this one sees this one, and this is the equivalent on the palindrome. So it can't be, it must be the same, which means it's not 1. So we have these ones seeing here, these ones seeing here, and this one can't be a 1. And then this one here sees these 2 by Knight's move. So actually we can fill a 1 right here. So these 1 see over here, and the 1 can't be here because 1 is odd, not even. So 1 is in one of those 2. But this one sees this by Knight's move. So the 1 is actually here. And I believe we can mark a few more 1's, but maybe not. I think that's all we really need to mark at this point. Feel free to do a little bit more there if you want to on your own self. But I'm going to start coloring. So we're going to be very careful about our colors because we're actually going to need a lot of them. I'm going to start fairly standard for my channel and use orange for odd numbers. So obviously all the circles are odd by definition of the rules of the puzzle, but also all of our 1's and 9's are odd because 1 and 9 are odd. That's pretty clear. And so this is kind of a key step to really break into the puzzle. So I don't blame you if you didn't see this, but if we think about row 5, column 5, this cell right here, whatever value is in this cell, let's just put a 3 here just for demonstration purposes. I'll remove it in a sec. This 3 couldn't be obviously in any, and we're looking at column 6. So where can the 3 go in column 6? We know it's odd, so it would be 3, 5, or 7, right? Whatever that digit is, so the 3 wouldn't be here. The 3 sees here by Knight's move, and the 3 sees this cell, which palindromically is equivalent here. This cell can't be a 3 because 3 is not even. And again, this cell's not even, it's an odd, right? It's a circle. And the 3 can't be here because it's a Knight's move away. And the 3 isn't a 9, and we know it can't be a 9 because there's a 9 already in the box. So that leaves just 1 cell for this, whatever this is. So I mean, I would fill a 3 here, but we don't know it's a 3, right? So I'm actually going to just mark that as odd. And we'll deal with what value it is later. We could try to remember that these 2 are the same, but we're going to, with like colors, but we're going to run out of colors pretty quick. So I'm actually just going to try to remember that instead of actually remembering that in a specific way. So now if you look, by filling that, we've got a bunch of evens that we can fill now, because for this box These are even. I'll use blue for even. And so obviously all of our squares are even. We can mark those blue. This is palindromically the same as this one. And this cell is palindromically the same as these two. So we actually get quite a few evens from that. And now if we look at row 9, we have 5 odds in that row. So all of these are even. And now we put an even on our pencil marked 9. So we can immediately just place this 9 here. And if we look up here, that means 9 is in one of these two, because obviously it's not even. And this cell has to be even. So that's pretty nice. So now what we're going to do is we're going to look at which evens are distinct from the other evens, if that makes sense. So, I mean, obviously all the evens are 2, 4, 6, or 8, right? And we don't know which is which, but obviously we have one of each in this box. So what we can do is, if we're careful about which ones we pick, and I'm going to pick this one here, we can pick a different color for that, and I'll pick green. And what that means is this cell is still even, but it's a specific one of the 4 evens. Hopefully that makes sense. So green is still even, but it's one of the 4 evens. We don't know which, but it's distinct from these other 3. And so we can find out where green must be elsewhere on the board. So obviously this green we know is replicated in these 2 spots, because again, we have this palindrome here, and then this is also a palindrome that duplicates here. So these 3 have to be equivalent. And so then if we actually look, we have greens are looking up into this box here. So one of these 3 has to be green. But if you look, these 2 cells are palindromically duplicated over here, right? This cell follows this palindrome around to be here, and this cell follows this palindrome down to be here. So these 2 are here, and they see a green as well. So greens can't be here, and greens can't be here because of the palindrome. So that means that this even cell here is also green. And we already knew that green was even. So that does match our expectations. Additionally, if we look at this box here, greens see here, and greens see these 2, and these are all odd. So we know green is even, so this one must be green, this cell here. And now if we look up here, greens are looking up here, and this green looks here, and this is odd, so it can't be green. So green is right there in box 1. And finally, I'm going to point out that if you look here, these 2 greens see here. The green here, by Knight's move, sees here. So green must be in one of these 2. And actually, we don't know that this is not 9, because this could still be 9 and then this is green. So we're going to get very confused for a split second about what green means in this context, but think of them as green corner marks. So we can't act on those too much yet. But if we also look at box 6 where green goes, well, clearly they can't go here. But this cell here is palindromically the same as this cell, and this cell can't be green because of that green over there. And so actually green is limited to one of these 2. And so now we have our greens for column 7 and column 9. They're in this kind of quasi X-wing pattern, if that's how you want to think about it. But we can also think about is where would green go in column 8? And it obviously can't go in box 3, and it can't go in box 6. So that means column 8's green is in box 9. And so it's one of these 2, but this green sees this one. And so green must actually be here. So we used the fact that these greens were limited to columns 7 and column 9 in order to place the green in column 8. And so now I am going to get rid of these greens because it would be very confusing to keep them up, because we're going to be doing things like counting how many evens are in a column and stuff like that. So we're just gonna remember it. I was thinking about corner marking some value that just happens to mean that, but I think that might get in the way later, so we're not going to do that. So now continuing on, if we look at box 9, we actually have our 4 evens, which means these have to be odd. And then in row 7, we just have the 1 cell left here, and actually that's the duplicate of this one. So we could have filled that a while ago, and I just didn't. Okay, so now if we actually look in box 5, where 1 can go, 1 can't go in this column because of this one, and 1 can't go in row 6 because of this one, and it obviously can't go where the green cell is because we know green is even, and it can't be where the 9 is. So 1 is actually in one of these two cells. And so then if we look up in box 2, 1 must be in one of these two cells. And so now, if you remember back early on in this solve, whatever was in this center cell, row 5, column 5, had to exist here because where else would it go in column 6? So these two are the same. So they look up here. They're odd, so they're not here. So just like the 1, they're in one of these two. 1 is odd, and whatever is in row 5, column 5 is odd, and so these two cells must be odd. And so now for the rest of the column, we're missing an even, so this cell must be even. And so now, if we think about it, we have the evens that are for box, the evens that are for box 8. We know they're all distinct, right? And we know where green is in box 5. And if we think about it, we also know where this one is in box 5 because it's repeated across the palindrome. So the question is, where are these other two in box 5? So we can ask about this cell, for example, in row 7, column 6, right? This cell. Where does this cell go in box 5? We know it's even, and we know it's not this one. We know it's not this one because of the knight's move. So we actually know that these two are also the same. So these two are the same and these two are the same. Because whatever's in this one can't go here, and it's also not green. And so the remaining of these, the remaining even is one of these three, and clearly these two aren't purple because it's in the same column. So that leaves only this cell for purple, which is repeated down here. And we can finish off the box and say these two are also odd. So now we have 5 odds in this column. So these two are even, and those are palindromically equivalent over here. So these two are also even. And so now in row 6, we're just missing 2 odds. So those two are odd. And also in row 3, we have our 4 evens. So the rest are odd. And this one is on a palindrome. So this one is also odd. And now if you remember, the thing I wanted to corner mark really badly in some way was that we have this sort of X-wing of greens, which are even. And so we can sort of think about how many evens are in box 6. Well, we already have 3 known, and one of these two is even. We don't know which one, but we know that that's the last even for the box. There's no more evens in the box, which means that this cell here must be odd. And additionally, we have column 5. We have our 4 evens for column 5, so these two are odd. And next, we have a moment where you probably, like me, when I was an hour and a half into my solve, forgot about the last rule about the sums of the palindromes. And believe it or not, now is the time to consider. So for both our F and our C, we actually know the parity of all the cells now. And let's look at the C first. So we know that the C has to add to 23. So we also know that we have 2 of the same even, 2 of a different even, right? So we have 2 blues and 2 purples, which are both even, and then an odd. So if you think about what the evens are doing, it's 2 times 1 even plus 2 times some other even. And if you multiply an even by 2, that result must be divisible by 4. And so both of those sort of the sum of the purples is divisible by 4, and the sum of the blues is divisible by 4. And so if you add those two together, you're preserving that, and that result is also divisible by 4. And so if you think about the 23, and we subtract whatever this orange cell is from the 23, that gives us the purple plus the blue sum. And so that must be divisible by 4. And so that lets us remove 2 out of the 4 odds as possibilities, because 23 minus 2 of the odds are not going to be divisible by 4. And so if we do that math, if you think about 23 minus 1, that's 22. Well, 22 is not divisible by 4. And so this can't be 1. In fact, it has to be 3 or 7. And if you think about that, if it's not 1, then it's 3, and then it's going to be 4 more than the 3. So 3 or 7. So that means this can't be 1, which means this one is 1. So that is a crazy step right there. And then if you look at where 1 can now go in box 6, can't go here because of these two 1s, and these two are even, so the 1 goes here. And so now, if you look, we actually have 5 odds in column 6, so we can actually fill these all as even. And because now we know where all our evens are in this box, if you remember, we actually had this sort of X-wing on greens. And this one must be odd for the box, and so this one ends up green. And so now we can immediately say, well, because of the X-wing, this one's green, which means it's not 9, which means we can place this 9, which means we can place this 9. And those are both odd, so I'll mark those orange. So now if you ask where 1 can go in column 9, well, these 2 boxes are taken, so it's clearly not here. And so it must be here. Another way to see that is the box as well. So these ones look up into box 3, and this one's even, and this one's 9, and 1 is not even, and 1 is not 9, so the 1 must go here. I'm in highlight mode. So there we go, 1 is here, which means now if we look, we now just have sort of this little box of 1s remaining. Those are the last ones, and we have all the 9s placed. So now we can do a little bit more coloring if you look carefully. So in box 2, where does purple go? Well, these two this purple seeing the other 2 evens, and all 3 of these evens, in fact. So this one must be purple. And so now we've distinguished 2 out of the 4 evens by coloring them, and we haven't fully found where they all are. Some of these blues may still be purple or green. But what we do know is, for example, these 2 cells in this box aren't purple or green, so we could pick another color for one of them. So let's pick gray for this cell here. And so that's obviously duplicated down here because of the palindrome. If you look, this cell here sees these 2 evens in box 9, so this cell must be gray. So now these 2 grays look up into here, and this gray here sees this cell, and so now the only even left in box 3 that could be gray is this cell here. And now those 2 look here, so there's the gray must be in row 3 for box 1, and it's obviously not the green, so this cell is also gray. And so now let's just pick this other one here and give it a different color. And I apologize that there aren't very many good colors left here. I contemplated using red, but as you can see, it doesn't really stand out that well, and I'm also worried about the colorblind. With this many colors used, I'm kind of worried about the colorblind anyway. I settled on yellow, and I really don't like it, but we're kind of out of color options that FPuzzles provides, so that's what we're going to go with. So this last 4th even is yellow, which is of course duplicated down here. And now what we'd like to know is which, within these 2 cells, we know that these 2 are the same and these 2 are the same. We'd like to know which is which. And actually in box 5, we know where purple and green are, so we need to find out where gray and yellow are. And so this is the best way that I can tell to distinguish this, is if we actually try gray here, which actually puts a gray down here, that gray really limits box 4. So this gray sees these, and this by knight's move, but of course this gray is seeing that and that by knight's move, and this gray sees here by knight's move. So it forces a gray into this cell here, and these see down here, and so we know gray is one of these three, so that puts a gray here, but we actually can't put a gray here because it sees both of these grays by knight's move. So it must be different than these two. So there may be a different way to see that. And do let me know if you see a different way of determining that. But that means these two are gray and these two are yellow. So now we actually do know a little bit more about this f. If you remember, the f needs to sum to 28. But we've put 2 gray cells on it. So it's actually 2 gray and 3 green, both of which are even. And in addition, this gray up here, which is the same value as these grays, is on an inequality. And so we actually know that the grays can't be 8 because they have to be less than blue, which is also even. So blue can't be 9. And there's also a 9 in the box already. So however you want to look at that. The options for gray are actually 2, 4, or 6. So we can narrow down actually to what the values have to be. If you think about what are the possibilities to add to 28 using 3 of the same even and then 2 of another even, and that other even can't be 8. So if we were to pick 6 for the grays, that's 12, and 28 minus 12 is going to be 16. And 16 is not divisible by 3, right? Whatever is left over has to be divisible by 3. Additionally, 4 plus 4 is 8. And if we subtract 8 from 28, also not divisible by 3, 20, right? And so with the 2's, that's the last option. Hopefully that works. They add to 4. You subtract 4 from 28, that's 24. That is divisible by 3. And if you divide it by 3, you get 8. So the grays actually have to be 2. So we'll do that. And the greens have to be 8. All right, so that's huge, obviously. And so now what we can do is we can go through the remaining blues that we have marked, and we can see that every single one of them sees both a green and a gray. Just go through it. These two see a green and a gray in the box. This sees a green and a gray in the row. This one sees it in the box as well. So these must be 4 or 6. Additionally, the yellows obviously aren't green or gray, so those are also 4 or 6. And the purples are 4 or 6. And I'm actually going to just take the remaining ones that are 4 or 6, and I'm gonna color those blue. So we're gonna keep those blue for the rest of the puzzle. It does reduce how many colors we're using. I'm gonna leave these other colors in just because we want to end up with kind of a pretty colored ending puzzle. At this point, you could probably remove the colors after marking the odds, and we are actually going to pencil mark the odds next. So it's up to you when you do your solve, obviously, if you want to remove the colors. I decided not to. So we can highlight all of these odds, and we have all of our 9s placed. And if I remove these 2 cells here, we have to be 3, 5, or 7. And all of these other ones, because we have all of our 1s placed except for these 4 here, where we know 1's in 2 out of these 4 in some X pattern. And so this is 1, 3, 5, or 7. And I missed these. These are 3, 5, or 7. And we can look to see if we shouldn't have any other eliminations here yet because we don't have any 3, 5s, or 7s placed. However, and again, here's where you could remove the colors, but I'm not going to. We have this inequality over here, so let's take care of that. We have a 4, 6 pair on an inequality, so obviously the 6 is bigger. So the 6 goes here and the 4 goes here. And then the 6 has to be bigger than this cell, so this cell can't be 7. And so next, what we can do is we can actually look at the C sum, because we actually know that these are all 4, 6. So we have 2 4s and 2 6s. And so those add to 20. And we know we need to add to 23, so I can do that in my head. That means this cell's a 3. And so that sees this cell by knight's move, and these 2 cells and this cell, so we can eliminate a bunch of 3s. And so now 3 in box 6 must be in one of these two cells. We can corner mark that, which sees this one. So this one must be 5. So here we have a 5 here. That eliminates 5s from these two. That makes a 3-7 pair here, placing a 5 here, which is mirrored here. So this one's not 5, this one's not 5, and by Knight's move we see here, so that's not 5. And this 5 sees down here, these two aren't 5, that's also true here. What I missed, these two are also not 5, so that palindromically comes down here. That puts a 5 into one of these two in the row. Okay, so next, now that we have this 3-7 pair here, we can do a little bit of Knight's move logic and say that this cell can't be 3 or 7. And so that should be pretty clear. If I put a 3 or a 7 here, it obviously can't be 3 anyway, but if I put a 7 here, that eliminates 7 from both of these cells, and so now I'd have to put 3 into both. So this cell's not 3 or 7. We also have a 3-7 pair in column 3, so this cell isn't a 3 or 7. So 3 and 7 are limited to these cells. I'm going to pencil mark that. This 3 sees over here, making this not a 3. And if you look, we can do some more Knight's logic. These 4 cells here, obviously these 3 all see up into this column, but also this cell here sees this cell. So the overlap of these 4, where we know a 3 and a 7 must be present somewhere in these 4. We don't know where, but it's somewhere. Wherever they are, they're going to see this cell. So we can eliminate both 3 and 7 from this cell, placing a 5. So that 5 then gets eliminated from here. It's also eliminated from here. That means 5 is one of these two. And 5 is going to be in one of these two cells. And now if we look at box 4, 5 here looks sees these 3, and this 5 sees these 2. So that actually just leaves this one white cell here to be 5. And so we can actually fill a 5 here and a 5 here. And these 2 are orange, because we're keeping up with our coloring here. Just for aesthetics, really. So now we can ask, where does 6 go in... Now that actually, we could have done this before, but anyway, we're doing it now. So this 6-4 sees this cell. We should have filled a 6 here a long time ago, and we have all 5 of our odds here. So these are both even. We know one of them's 4, and the other one's going to be 2, and this 2 sees down here. So this one's the 4, and this one's the 2. We'll mark the 2 gray. These two these 2 2s see into box 4, putting a 2 here. That's a bit of a tongue twister. Maybe not. Maybe I'm just not good at talking. So that's all of our 2s. So that's awesome. And so now here we have a 1-4 pair remaining. So we might as well mark that. This is going to be a 3, 6, or 7. And we can of course propagate some of these other things we placed. So this 5 here sees here, so this is 7, 5, 7, 3, and a 5. And this 3 is duplicated here to make that 3 and 7. That eliminates a 7 from here and from here. And also from here, which we actually already knew. And in fact, this one is a 4 or 6, which we can mark blue. This 7 here sees up here, so this is 3, 5. So we can eliminate 3 and 5 from these. Get rid of the corner marks as well. And if you look, we had this 3 here. That places a 7 here. That sees this by Knight's move, placing a 1 and a 7. That places 4 and 1. So we can mark the 4 as blue and the 1 as orange. This is no longer 7, so that's a 3-6 pair, so this should be fillable. And it is a 7 as well. And so now that sees here that this is a 3. And so now this one is also a 4 or 6. This 7 also sees down here. So that leaves just one place for a 7 in this box. So that places 7, 3, and 7. And this 4 here by Knight's move sees this cell. So this is 6, 4. That palindrome's down here to 4. That makes this 6 and comes back up here to make this 6. That makes these two 4 because it sees them both. Marking this as 6. This 4 sees this by Knight's move, making this 6 and 4. And 4 is greater than 2. So that's good. And just finishing up, the 6 is seeing into here. So this is the only place for a 6 in the box. That makes this 3 and 6, which I will color immediately. And so now this one can't be 3. So here's the 3, which is orange. This 3 sees over here, making this 7 and 3. And finally, the last one for the box is a 4, and it is blue. So that is how you solve Fight Club. Hope you enjoyed the solve. There were definitely some interesting logic going on there. I think there's a lot of different ways we can color it. When I attempted to live solve it, I tried to color every single number a different color. And I think if I had more colors at my disposal, that would have been easier. But even then, I think that was working out pretty well, other than the mistake I made early on, which was just making the puzzle fail. So that's an interesting strategy as well. I'm wondering if anyone tried that. Another strategy that I think worked pretty well is after I did a little bit of coloring, I attempted to I picked random numbers to fill in, and I ignored the sums, and I ignored the inequalities. So, and then the hope was at the end, I would then flip around the numbers. I kept the parity, so I only filled in a number to a cell that I knew was even or odd, and I filled it with an even or an odd, so I could still use parity. But the inequalities I completely ignored and didn't do anything with the pencil marks there. And that did allow me to, like, with the different colors, it's hard to keep track of, oh, this is a blue-gray pair or something like that, or there's corner marks in these cells for that, which does elimination. So let me know how you got on, if you did manage to solve this, what kind of strategy you used. Was it one of the ones I mentioned? Was it something else? And if you want to see more videos like this, make sure you subscribe so that you can have that show up in your feed. Please leave a comment. I love all the comments. I love to know that people are watching and enjoying my videos. I love to get the feedback on what you guys did that was different than me, or what you did that was the same, how long it took you to solve the puzzle, whatever you want to do, whatever you want to comment. I just love seeing those comments. I love seeing you guys interact with me and that you're enjoying the videos, and that really pushes me to make more and to do better on them. So thank you for watching. Hope you enjoyed this, and check out some of my other videos.